Hi, welcome everyone to Every Part Plays Its Part, Selecting Inlays and Chips. I'm Elizabeth Stoll. I lead our Global Applications Engineering team for Avery Dennison. I'm joined by Hal Hakita, Head of our Global Product Management.
Hello, everyone. Pleasure being here.
Thanks, Hal. So today, we're going to get into the technical side, or more specifics about the RFID tag technology itself and some considerations and tips there. A little bit different focus than the rest of the bringing RFID technology into your business to really use the technology to its fullness. Part of that is selecting the right tags for the use. So first we'll put RFID into context, why it matters. Second, we'll go as a very high level, a lot of different details there around inlay selection, including design and chip trends, and then we'll finish off with our combined Avery Dennison and Smart Track portfolio. So first to start with, why use RFID at all? What are those benefits? And the phrase I love here is RFID bridges the physical to the digital. It bridges the physical to the digital. So if you think about it as a pyramid, we have this base here that we're physically placing an RFID tag onto your item, which uniquely identifies it, unique in all the world. So instead of having 10 of the same item, you have 10 unique items of the same type. So once we've uniquely identified it, the reader can very quickly read that unique identification with a fast read, usually not line of sight, usually reading several tags at once. And those types of reads can be automated. This means we're quickly reading a unique item in space and time, and that could be put up into the cloud, connected with our IT systems, and suddenly we have a very good visibility of all of our items using RFID technology. Now, looking at the RFID tag itself, there's a couple components that are really critical to the product. And you really can't have a tag without the chip or antenna. Those are the crucial components there. So the chip is silicon. It has an integrated circuit. It's got memory, many different features and options that we can talk about, but there's some base features that are normally used. And that is activated and communicated with through the antenna, which they come in all different shapes and sizes. They're some kind of conductive geometric shape, usually made of aluminum today, and that's connected physically to the chip to help that chip communicate with the rest of the world. And those two pieces are put on some kind of carrier, so very thin laminate, usually PET if it's been etched. It could be paper, which Avery Dennison is very proud of our paper substrates, getting rid of the plastic, or even something as flexible as a fabric. So you've got the chip and the antenna, and that's really the brains in the crux of our RFID tag. Now here on the right, you see RFID inlay, RFID tag. You'll hear these terms used interchangeably, and don't stress about that. You'll probably hear Hal and I use the terms interchangeably too. But if you say inlay, you normally mean an unfinished product that's just really the chip and the antenna that's going to be put into a label or ticket. When you're talking about tag, you're most often talking about something that's finished, ready to be used. So it's already in the label form, it's functional. You can go ahead and use that RFID tag. And just thinking a little bit more how RFID inlays fit into the traditional standard label concept. So our standard label, you've got probably a laminate, probably a paper with a functional adhesive. You've got something printed on it, so it's human readable, it's barcode scannable. Once you insert into that an RFID inlay, now you've married in this technical piece with the chip. So now you're encoding in the chip some kind of identification that matches up with your human readable and barcode scan. So it becomes this very useful thing that you're now placing on your item that you can read quickly through RFID, or you can still use in the traditional sense. Now, identifying RFID in the wild, UHF RFID in particular, and then also NFC that Hal will talk about, both becoming more and more prevalent around us. So as far as UHF, you might be surprised to know that if you go to the store today, you probably are surrounded by quite a bit of RFID already. So on the left side here, for some examples that I found around my own area, are a hang ticket and a label that was placed on some clothing. And the clue here for me is this little EPC logo. EPC stands for Electronic Product Code, and that would indicate that there's a UHF RFID inlay in that ticket or label. Sometimes with labels, because it's a thin laminate on top, you'll see the chip bump through it, or you might see the faint trace of an antenna there, and that would also indicate you're seeing RFID. On the right side there is a baggage tag actually from one of my flights a couple of years ago. I took it off my bag and held it up to the window, and lo and behold was a Avery Dennison inlay in there. So that had actually been able to allow the airline to track my luggage as I checked it in and as I picked it up again. Now, how does RFID work? When I talked about the parts of the inlay, I did not mention a battery. So how is it that we're now putting electronics essentially into our label? Well, it's a passive technology. It's using RF harvesting. The reader is sending a signal that the antenna is able to capture and charge up that little chip and start to do its communication with. So that way we don't have a battery, and it really allows for flexibility and ease of use for the RFID. Now I'm going to pass it over to Hal to talk about more about different types of RFID technology.
Thank you, Elizabeth. Regarding the general differences between UHF and NFC inlays and tags, for UHF, the readers are designed to read multiple UHF or RFID tags within a given read distance. Passive or batteryless, as Elizabeth mentioned, UHF RFID tags can be read up to 5+ meters away, 5 meters or more. This requires that UHF RFID readers that are specifically designed to read UHF RFID. As of today, commercially available RFID readers are not, commercially available RFID readers are not yet in smartphones. Primary use cases for UHF RFID include inventory visibility, supply chain traceability, and loss prevention. On the other hand, for HF NFC RFID, a reader connects with a single tag primarily because both need to be in close proximity in terms of centimeters or inches. You will hear some speak about tapping the NFC tag to describe how to interact with the tag. But all you need to do is to get your reader within reading distance of the tag of interest. NFC readers for consumers are ubiquitous because Android and newer iPhones can read NFC tags natively, meaning that you don't need an app. For older iPhones, older than iPhone 5, you will need a third-party application. The primary use cases for NFC tags includes tap payment, consumer engagement, closed-loop applications, and we'll go into more details on the next slide. When we speak about consumer engagement, this involves connecting the end user to experiences related to the product with the NFC tag. A consumer experience can be a mobile app or a website, which may contain multimedia usage, sustainability, or safety information about the product. Another of many NFC use cases may include helping the end user shop or find exclusive deals for related products. With NFC, we can even provide secured consumer experiences, which means that when an NFC tag is read, it directs only authorized end users to a particular experience. Non-smartphone NFC readers are also used for closed-loop applications, such as in the case of consumer appliances with mating parts that need to have programmable behavior when brought together. NFC applications also include reverse logistics applications with respect to OEM and manufacturing workflows. NFC-based tamper detection is often used to ensure brand protection, to guard against product counterfeiting and diversion. Now that we've given an overview of RFID, as it relates to UHF and HF NFC tags and inlays, let's dive into how to go about selecting the right inlay. First and foremost, you will need to know what business value you will be driving with RFID. Specifically, you will need to understand which applications and related use cases must be satisfied as it relates to successful deployments. The target application and use cases will also help determine the size and construction of suitable inlays based on the size of the object to be tagged, and the material the object to be tagged is made from. Other key application considerations also include RFID reader environment. For example, where will the readers be located, and the line of sight and the direction of the reader with respect to products with the RFID tags. We'll touch upon each of these areas in more detail shortly. In terms of breaking down the inlay selection process into simple 3 steps, step 1 is really about, again, emphasizing that the application drives requirements. This requires a clear understanding of target RFID application, use cases, and workflows. For example, if the application use case is to track and trace products, is tracking pallets or batches of these products good enough, as in the case of traceability across the supply chain? Or will you need item level traceability required, as in the case of in-store cycle counting and inventory management? You will need to know more information about the item that's going to be tagged. How large is it? What is it made of? How is it handled? How will it be read or scanned? What kind of environment are the objects in when scanned? Step 2, again, regarding the application, another question asked is what performance is required? What read range is required based on the distance from the RFID reader to the objects that are tagged? Is there a primary direction or orientation that places an inlay in the line of sight of the reader, or does the inlay need to be read equally from any direction? Regarding IC features, does the target application require high performance and therefore higher IC sensitivity? Does the target application require more IC memory to store information about the object being tagged? What are your converted and delivery formats? If the target application requires specific converted formats, will it make do working with dry inlays, or would you prefer wet inlays? Will you need easy peel adhesives, or do you have special liner requirements? Other considerations include your converting equipment. Do you have certain pitch requirements, layout requirements, or orientation requirements? And finally, as it relates to encoding, do you have any special encoding requirements? Step 2, once you understand the application requirements, these requirements drive capabilities. Once application use case requirements have been determined, the next step is to align these requirements with the capabilities of available inlays. Excellent resources that help describe UHF capabilities include certification programs such as the ARC program hosted by Auburn University's RFID lab. For HF NFC, the NFC Forum certification program is an excellent resource to help with HF NFC inlay selection. You should also rely on inlay data sheets and application notes from the inlay manufacturer to facilitate the selection process. And if special inlays are needed, major RFID manufacturers, such as Avery Dennison, can support new development requests. Step 3, test and validate. After you've down-selected your desired inlays, the next step is to simulate real-world scenarios and use cases, and continue to test to ensure that the performance meets the requirements of the applications. Generally speaking, larger form factors mean larger antennas and better RF performance in terms of sensitivity and range. However, application requirements will also include item size. In other words, what is the size of the item or object that you wish to tag? Using the previous examples, pallet level tracking means tagging containers, which means that you could probably get away with larger form factors in terms of inlays. On the other hand, if you need item level tracking for small products such as garment labels, jewelry, accessories, or even pillboxes, you will need to rely on inlays with much smaller form factors. Here, we show a subset of our combined Avery, Dennison, and SmartTrack UHF product portfolio to illustrate various inlay sizes and form factors driven by global customers as well as industry specifications. Likewise, here we show a subset of our combined portfolio for HF NFC RFID products to illustrate various inlay sizes and form factors driven by global customers, as well as a broad variety of HF NFC applications and use cases. At this point, I'm going to hand it back over to Elizabeth.
Thanks, Hal. So I'll go through a couple more things to consider when looking at that type of broad portfolio of options for your tags. So Hal rightly talked about the size and available space to place an inlay. The larger the better, that's great, but also the item itself, that material will change the performance of the tag. So tag designs, you see that broad number of tag designs, they're actually each optimized for a set of materials or types of items to read most optimally. So looking at the full value chain here of the environment of a read point, you have the tag on the product, the environment around the tag product, and the reader and antenna hardware trying to read the tag on the product. And all of those will have a direct impact on exactly your read performance of the tag. So consider the material of the product, consider the density of the products together, the environment, are there any harsh RF things like metal or liquid nearby? And then is that reader and antenna really set up to optimally read that tag? And is the tag presented to the reader well? So with that in mind, especially for UHF RFID, wanted to bring to you a couple of considerations to really think about. And these are specific to UHF. So metal does interfere with that RFID signal. It's an RF signal. So if you can imagine the radio signal trying to go through the air, a metal will block it if it's between the reader and the tag. Likewise, if metal is near a tag, it will actually detune it. And that's true for both your UHF and HF NFC tag. Thankfully, we have solutions for these cases. If you're trying to put a label directly on something metal, we have on metal tags, we have flag tags, we have NFC on metal tags that are very thin form factor that can go directly on metal as well. So just be aware that you're looking for the right solution if that's in your use case. Another thing to consider, high dielectrics such as liquids, glass, rubber. If your item contains these things, these types of material are very dense from an RF standpoint. It does two things, is that it actually changes the tuning of the label or tag once that antenna gets close to this type of item, and it changes the performance a little bit. Also, it's absorbing the RF energy, so there's less energy there to respond. Again, we have a couple, depending on what it is, different tagging solutions. So just be aware that you're looking for a tagging solution that's addressing these types of material tagging. Tag orientation, this is just another thing to consider as you're trying to set up your total RFID system. As you saw on the pages before for the UHF tags, there are many different shapes. Most of them are rectangular if you look at the outside shape, and it's going to be longer one direction than the other. If you think about a tag antenna as something that will be absorbing the radio frequency energy and then reflecting it back, it makes sense that that long edge, if you're approaching the long edge of it, you're going to get a stronger return signal than if you're approaching the short edge. And it results in the fact that you will get a much longer read distance if you're approaching the long edge with your reader than if you're approaching the short edge. So orientation is another thing to think about. Again, lots of things here, but nothing that can't be solved. So just talk to your Avery Dennison representative when picking out a tag here. And now I'm going to dive a little bit into some technical aspects here about the technology for UHF, and that is the frequency region that might be used by the reader. So RAIN RFID is used all around the world, which is fantastic. What might be different is that each region of the world is trying to make sure that different RF devices are not interfering with each other. So cell phones are using different frequencies in Because of that, we want our RFID readers to not interfere with the cell phone signals. So if you look on the right side here, you actually have your different governments calling out requirements for different frequencies used by the reader. So, but let's pause that for a second and look at this plot in the middle. You might be familiar with this plot. There's many in our data sheets. At the end, they'll talk about the tag size and the form factor, et cetera, and then there'll be this plot. And what you're looking at is a representation of each line is showing, depending on the frequency and depending what material it's on, it's going to get a different read distance. So for instance, that top blue line, if you have this particular tag, you've put the label on plastic, PTFE plastic, and you go sweep, your reader uses different frequencies, it's going to get different maximum read distance. The nice thing to notice is the tag is working in all of these frequencies and on all of these different materials, not a problem. It's just that if you're trying to optimize your read, you will probably want to choose a tag that's going to read further with the material in that region. So there's two things to consider here. One, if you are in a global deployment, you want to know which region are they using the FCC or ETSI focused frequencies. And if you're using a small tag, that probably means you'll want to use either an FCC or ETSI focused tag. And then the other consideration, of course, is just checking how that tag is tuned with respect to different material types. Again, something a little bit more technical, but nothing that hasn't been solved and can't be handled by your Avery Dennison representative. And here's a view of example of one of our data sheets and application notes, and I'll hand it back to Hal so he could talk further about other things you might find out in these data sheets about the tags.
Thank you, Elizabeth. Let's take a deep dive into an inlay and let's zoom in on the integrated circuit microchip, or as we simply call it, the IC. Generally speaking, newer ICs perform better than prior IC versions, but always check whether or not special IC features such as user memory or secured authentication are needed. Let's talk about IC sensitivity. A higher IC sensitivity lends to better RF performance, and in general, all IC suppliers have been trending towards higher sensitivity. The other trend worth noting is the IC form factor. IC suppliers are increasing wafer size while at the same time shrinking IC die size. IC manufacturing companies are also continuing to move to smaller technology nodes, which means IC manufacturing processes are continuously evolving and improving. So that's a key thing to note about as you pick inlays and you're selecting inlays with newer ICs, some background information regarding those ICs. And finally, a third important aspect of an IC is the memory size. IC suppliers will also adjust IC roadmaps in accordance to memory requirements as driven by the market. Now, if we can go to the next slide, we can double click into these topics. Regarding UHF IC or chip capabilities, for memory size, as it relates to ICs for RFID applications, retail applications tend to keep memory requirements lean and rely on standard memory to support EPC and GS1 standards, as opposed to industrial segments, which may require larger user memory capacity for storing product information with the tag. There are other specialized IC features that you should take into consideration. For example, RFID securitization has become an important topic from a brand and product authentication perspective. IC encryption is a related and critical capability that enables RFID securitization. So once you have gathered all of your application and use case requirements, there are key resources available that can help in terms of aligning these requirements with inlay capabilities, such as the certification program hosted by Auburn University's RFID lab. That program is called ARC. ARC has actually two certification programs. The first one is the manufacturer quality certification program, which ensures that an RFID tag manufacturer will design and manufacture reliable, high-quality RFID tags. Manufacturers may be required to be ARC quality certified before they can submit tags for performance certification, which is the next type of ARC certification. And that is Inlay or tag performance certification. So for this, ARC works with end users and key segments to identify performance and quality requirements for their use cases and deployments. These requirements are the basis of ARC specifications as shown here, and RFID tags that are designed against these specifications must perform with respect to the test criteria defined by these specifications. Regarding NFC inlay and tag certifications, the NFC form certification program confirms that an NFC device, tag, or reader is compliant with NFC form specifications as shown here. Conformance to the specifications provides consistency of behavior across NFC implementations and sets the foundation for interoperability. As it relates to converting, here's some key tips to take into account. First of all, to emphasize again, an RFID inlay or tag is an electronic device with a microchip and antenna. It must be handled with care to ensure mitigation or avoidance of damaging the IC, the antenna, and/or the IC antenna connection. For ruggedized applications, ruggedized inlays are available for which additional measures are taken to protect the IC antenna and IC antenna connection. Key considerations must be taken with respect to the RFID work environment, as well as RFID inlay and tag handling through production and packaging stages. We provided tips based on our experiences here. Continuing with our converting tips, as it relates to encoding and testing, encoding the IC can be done during the imprinting process or in a separate unit. The key takeaway from the tips shown here is to make sure that the printer of interest, whether it's a laser printer, variable information printer, or any other kind of printer, that the printer is specifically designed for RFID applications. As it relates to testing, some key tips include ensure that you have at least 2 inline testing points, one before and one after the converting stage. Properly configure an equipment to read and test inlays one at a time and optimize processes to avoid typical inlay failures during converting, such as yield loss due to mechanical stress, ESD, and etc. Failed or underperforming inlays and tags can be marked or replaced depending on your service level agreement with the customer. So to wrap things up, a few high-level summary of best practices for selecting tags and inlays boil down to, number one, in general, larger form factors mean larger antennas and better RF performance, and newer ICs in general perform better. However, it is the target application and use cases that ultimately drive inlay requirements. Pay particular attention to required workflows, target objects to be tagged in terms of size and material, and RFID environment in terms of reader location and directionality. Also check whether or not special IC features such as memory or secured authentication are needed. Select inlays by aligning inlay capabilities with application requirements using certification programs, inlay manufacturers' data sheets or application notes, and pilot programs. And validate that inlays and tags meet application requirements by testing and validation. Now that SmartTrack is part of Avery Dennison, We are the largest global RFID designer and manufacturer with the richest and broadest portfolio of inlays, hard tags, and sensors across all RFID frequency bands to serve key applications in retail and industrial segments worldwide. Please visit our new product website and use our new product finder to learn more about this portfolio. At this point, Elizabeth and I would like to thank you for the opportunity to present today, and we're available to answer any questions.